Okay, we're at the bottom of page 3. This video is going to talk about the exterior angles in a polygon. So we talked about exterior angles with triangles already. You can draw exterior angles with polygons as well. You'll just take one side and extend it in one direction. So you make a ray, and the exterior angle is what you'll get from that extended ray and the next side of the triangle, or I'm sorry, the polygon. So you'll see this is a pentagon. It has 5 sides. It has 5 interior angles. It also has 5 exterior angles. There's nothing that said we had to draw the pinwheels going this way. This kind of looks like they're counterclockwise. You could have drawn them going the other way. Let me see if I can just do that real quick. So this angle 1 I got when I extended this bottom side to the right. So if I extend it to the left this way, that'd move your angle 1 over here. And then you can do the same thing with 2 and 3, 4, and 5. Okay, so those are another way to draw the exterior angles of a polygon. So the theorem says, just like for the interior angles, there's a pattern with what these will always add up to. And hopefully I have time to explain in class why this is true. But this one's the easiest pattern that we have between anything. The pattern is going to be that they always add up to 360. So there's only one number to remember. The formula is it equals 360. Always adds up to 360. Okay, and the reason is, if you imagine walking around the whatever polygon you're doing, so let's say you start right here, okay, and if I'm going to walk around, when I get to this vertex, I have to turn my body. So you imagine I'm walking and I'm facing this way, and then I turn my body this much so I could go up the next side. And so the amount you have to turn at each vertex is actually the exterior angle. Okay, so imagine walking around any polygon. You turn at each polygon so you can go down the next side. And since you're walking around the whole polygon, you're basically walking in a circle. It's a pointy circle, but it's still a circle. And hopefully you know that a circle is 360 degrees. And that's where this 360 degrees comes from. Okay? So on the next page, if you need to find an unknown exterior angle, all you need to do is write an equation. I know all of these should add up to 360. I'm going to need a calculator. So I'm going to do 5x plus all of those. And we have 62 plus 35 plus 69 plus 41 plus 58. 62, 35, okay, that's 265. So we're going to have 5x plus 265. Then I'd subtract 265 on both sides. Is 95. And then divide by 5. That x is 19. But if I tell you to find the measure of the unknown exterior angles, I'd have to do 5 times 19, which is 95. Oh, I knew that. 5x was 95. Perfect. Okay. Now it says, what is the measure of an exterior angle of a regular nonagon? Remember, regular means all the angles and all the sides are the same. So if all the interior angles are the same, the exterior angles are also going to be the same. So let's see here. I know that all of them should add up to 360. And a nonagon, I know, has 9 sides and 9 angles. So you just take 360 and divide it by 9, which is 40. And that's your answer. Okay, before we move on to the practice, it's important to note that if you look at any interior and exterior angle, so right here, let's take the 58. The 58 is the exterior angle. The interior angle is right here. Those two angles are a linear pair, so they are always going to add up to 180. So I'm going to write myself a note. Every interior angle plus the exterior angle that it's attached to will always be 180. That sometimes helps you to check your work with some of these problems. You'll notice that if I took the interior angle of a regular nonagon, it should be supplementary. It should add up to 180 with 40. So remember, to figure out what the interior angle would be, you go 9 minus 2 times 180, which is 7 times 180, which is 1,260. And then you would take that and divide by the number of angles, which is 9. And you got 140. And that is correct because these two add up to 180. So that's just a quick way to check yourself. I know in the test they'll ask you for the interior and exterior angle of a regular some shape hexagon or something. Okay, so I want you to try these practice questions now. Pause your video, turn it back on to check your answers. Okay, so this says cross out the shapes that are not polygons. So this one is not. You can't have an X in the middle. This is an angle. This here has got a curved side. This one, it's not closed, and you have more than, or this segment who ends right in the middle of another side. So that doesn't work. So only two of these were polygons. Next one, supplementary angles are two angles whose measures sum to 180. Suppose angle X and angle Y are supplementary. If angle X is 75, so to find Y, you do 180 minus 75, which is 105. Underline the correct word. A linear pair is supplementary. We just talked about that. Angle AFB, that's 60, and EFD is 120. So we have 60 plus 120, that's 180, so that's supplementary. Use the diagram at the right, draw a line from each angle to a consecutive angle in column B. So angle A is next to B and F. And F is the only one here that is one of those. Okay, so B is next to A and C. So that one doesn't have one over here that we can draw. Angle D is next to E and C. Let me do that. And then I don't know why I thought I had ones matching up with everything. So let's change this to angle D could be either angle C or angle A. So let's put angle C. No, we better not put C. Let's put A. Perfect. Now practice them on your own.